Good afternoon, everyone. So I'm here with 8 examples of different conjugated dienes and conjugated double bonds, rather. So we walk around. We are going to discuss on the identification of all the different kind of oxochromes that we have. Don't forget we have what we call chromophores and we have oxochrome. Be reminded that oxochrome are the substituents that increases wavelength. They cause increase in absorption. Do you understand? So now to number one. Looking at number one here, this compound here. First of all, you need to know what kind of compound is it. What kind of group does it belong to? When I'm saying what kind of group, what I mean is it an alpha beta unsaturated ketone? Is it an alpha beta unsaturated aldehyde? Is it an homoannular compound? Is it heteroannular compound? So looking at this compound, first of all, realize that this compound is an heteroannular compound. Why is it heteroannular? This is because the conjugated double bonds are not in the same ring. Whenever the conjugated double bonds are in the two or more different rings, for example, now if this ring is ring A, if this is ring A, B, C. So there's a double bond here in B and there's a double bond in C. So this double bond here in B is conjugated with the double bond in C. So whenever we have two different double bonds that are conjugated together and they are not in the same ring, they are in different rings, then we say they are what? Heteroannular. And so the standard, so we can say heteroannular is like there's a particular constant value in the Woodward Feiser table. So the heteroannular diene has a value of 215 nanometer. So this is the base, or we can say the parent value. So now we go ahead by looking at other features that are present in this particular compound. Looking at this compound very well, this compound has exocyclic double bonds. Now, from the video I did previously, I explained that exocyclic double bonds are those double bonds that are at the junction of a ring with another ring. What I mean is that whenever you find a double bond that is connected to another ring, for example, now this double bond in B is connected to ring C. Looking at this double bond here too, double bond in C is connected to ring B. So after you are able to confirm that, then you now check this double bond here. It is connected to ring C, but it is outside of ring C. So whenever the condition is being met, then you will conclude that the double bond in ring B is exocyclic to ring C. So that is one exocyclic double bond. Then if you look at this double bond here too, the double bond here is exocyclic to B because it's connected to B and at the same time is outside B. So that is what? Another exocyclic double bond. So therefore we have what? Two exocyclic double bonds. Now, ring residues. This is another feature also that we can find in the Woodward Feiser rule. For you to be able to identify ring residues, it's very simple. Ring residues are the residues left from the conjugated double bonds on the rings. That is, this, as we all know that this is the conjugated double bonds we have. This is conjugating with this. So all the bonds beside the conjugation area, they will have ring residue. That is, this bond here, we have a residue on it. This bond here, we have a residue on it. This bond here, we have a residue on it. This one here, we have a residue on it. Note, the ring residues must always be on a ring. That's why we are calling it ring residue. The residue should never be on a substituent. It has to be on a ring. And note something here, that there can't be any residue here. Reason is because this particular bond is the bond involved in the conjugation. This bond is between two double bonds that are conjugated together. So there won't be residue. The residue will occur at the surrounding of the conjugation. This, like this, is the conjugation. So the surroundings, that is a single bond after. So the single bond after this conjugation is here, after this conjugation is here, after this one is here, after this one is here. So we have 4 ring residues altogether. So that's what? 4 multiplied by 5, that's 20 nanometer. So by the time we check all this very well, realize that we don't have any feature. Yes, I heard someone telling me that what about this alkyl and alkyl? This alkyl and alkyl here, they are not oxochrome. This alkyl here is not serving as a substituent. This alkyl here is not going to be increasing the absorption of this chromophore, this particular compound. this conjugation. Don't forget that this conjugation is the chromophore. It's where the absorption is taking place. So let me just say it this way. Whenever you find an alkyl substitute, an alkyl, methyl, or anything, when you find it in between two or more rings, it's mostly not significant. So we won't put that into our maximum value. So that's for number one. So the lambda max for number one is 245. So I'll be doing the videos short so as to how will I say it now? So I will not waste our data, so we can be watching it one after the other. Thank you.